convert a recurring decimal into a fraction. Now, this decimal, I'm going to label it as x, and this should be your starting point for every one of these questions. Now, a recurring decimal is a decimal that continues on forever, so it's the opposite of a terminating decimal. And this continues forever. Okay, so we need to write this using algebra, so we can't use a calculator to answer this question. Okay, so what I want to eventually get to is a decimal where I have eliminated the recurring part. Now I'm going to try and do this by finding multiples of x. So if x equals 0.22222, then 10x, well, I'm multiplying it by 10. To get from x to 10, I've multiplied this by 10. If I multiply 0.22222 by 10, my digits are going to move one to the left, so I'm going to get 2.22222 recurring. Okay, what you will notice now is that if I actually do 10x subtract x, that's going to give me 9x. So if I do this, subtract this, I get 9x. Now if I subtract this whole equation from the green one, I will then eliminate the recurring decimals. So if I do 10x, so I did 10x minus x equals 9x. So if I'm trying to rewrite these two this way around, and I'm going to subtract one from the other. Okay, 10x minus x is 9x, as we've just said. And if I do 2.2222 recurring, subtract 0.222 recurring, well, I'm going to cancel out the recurring decimals. So I'm going to end up with just 2. Okay, well, to get x on its own, I need to do the inverse and multiply by 9. So x is equal to 2 over 9. And that is your answer. You have written a recurring decimal as a fraction. And you can actually check your answer. If you type 2/9 into a calculator, you will get 0.2222 recurring. Okay, we're now going to go through another example just to show you what happens when we have two numbers. So my starting point is going to stay the same. I'm going to label my decimal as x, 0.18 recurring. Now I always like to write out the first few digits of the decimal, just to remind myself what the actual recurring decimals are. So 18, if the dot is above both numbers, that means both numbers are recurring. So my decimal is 0.18, 18, 18, etc. Okay, I'm going to use the same method to try and eliminate the recurring decimals. So I'm going to multiply x by 10. 10x, if I multiply this decimal by 10, all the numbers move on to the left. So I'm going to have 1.818181. Remember that my aim is to line these decimals up so that eventually I can subtract one from the other. But what you'll notice here is that these numbers, these digits, do not match up. So I'm going to multiply this by 10 again to get the value of 100x. Because when I multiply this by 10 again, all my numbers move on to the left again. So I'm going to have 18.181818. And what you should hopefully realise is that the decimals line up for my value of x, 181818, and my value of 100x. So I'm going to subtract x from 100x. So I'm going to write that here. 100x is equal to 18.1818, etc. X is equal to 0.1818, etc. If I subtract one from the other, 100x minus 1x is 99x. And if I subtract this decimal, I eliminate the terminating decimal, and I just end up with 18 subtract 0 is 18. And to get x on its own, I need to divide both sides by 99. So my answer is 18 over 99. Again, you can type this into your calculator to check, and when you type this in, you should get 0.18 recurring.